morning. Thank you very much. I definitely want to thank Tobin, Gunnar and the whole BIMS team as giving me the opportunity to come here and speak about the Opera House. It's an incredible building to work in, and unfortunately it's one of those buildings that no matter wherever I go on holidays, I see work in a brochure or a poster or something come to Australia, and the thing that's always used is the Opera House as a point of reference. So I trust this presentation is going to take you on the 11-year journey that I've been on from the time it first commenced, and give you some of the insights of the issues that we had on the way through in this project. My official title was the Building Information Manager, and I had 3 roles there, which was looking after the model, spatial information, and the technical library. But as of last Wednesday, I got a new title, and now all of a sudden, I am the Implementation Manager, and moved to the next stage, and effectively the final stage of this 11-year journey, which is getting it working and making certain that everybody in the building benefits from it. And it's not just the people in the building, but it's also contractors who work with us and design and develop projects within the building. 4 topics were suggested that I cover. What were the reasons the Opera House commenced within the journey, the processes we used to implement it in, the benefits we hope to achieve and have already achieved from them, and then the final thing, the problems we had to solve on the way. And before I could go into those, I think I need to give you a little bit of an understanding of what the building is like. It is not just a single solitary performance space. It was 15 years of construction from 1958 until 1973, and in that time there was the cost of it. The first stage was estimated to be $10 million in 1965, and if you convert that to Australian 2014 figures, it's about $254 million. I used the currency converter only last week to sort of bring it into current Danish terms, so you have an understanding of what the value of the building was at that time. Its prime function, its valuation at the moment, which is quite interesting, is $2.35 billion. And that is basically the value of the assets within the building, the machinery of the building, and the actual structure and the land that it sits on. It sits in one of the prime real estate areas in the whole of Australia. It was internationally developed, and a lot of the resources came from Europe. A lot of our companies, our drawings and documentation had names like Wagner, Bureau, Stenson, Arab, to name 3 of the group that sit there. It is primarily a performing arts centre. That is its prime role. We have in excess of 1,800 performances per annum, which is about 5 per day. And you wonder how can we put 5 per day, and see how the structure of the building is actually not just one space, as I said before. It is a mix of many performance spaces. We have 7 performance venues, 78 rehearsal and dressing rooms, a recording and broadcast studio that broadcasts these days internationally through the internet as well, so we do live broadcasts online for performances. Last year, I believe, the Danish Awards Festival for young people was done directly from our performance at the Opera House using our facilities. It's a small performance multimedia room, but they managed to squeeze in about 15 directors, producers, the whole ensemble was sitting in this small space. From the tourism aspect, it is our prime tourism destination. 8.2 million people visit the site on an annual basis, and we conduct in excess of 7,500 tours per day. Multilingual tours in Asian, German, Italian, Chinese, Mandarin, Japanese. It starts at 7 o'clock in the morning and goes until 7 o'clock at night. You can have breakfast in the green if you want it. And then At the moment, its national worth is $4.7 billion. And that is basically working out all the extended jobs that are given to people who are associated with the building. So it's that volume of input that comes into the building that has this unbelievable worth of 4.7 billion Australian dollars. The building operates 365 days a year. It says up there 363, and it works 24/7. The 2 days that we are closed are the days that the electricity team get in and are actually able to turn off the main distribution boards and clean behind them. And that is on Good Friday and Christmas Day. So we do work 365 days a year. As I mentioned before, the rehearsal spaces, the dressing rooms, 2,460 rooms in the building, 17 levels, from basement 5 up to the roof of the building. 57,500 square metres of usable space, covered usable space within the building. 6 escalators at the moment. Escalators are not very big. They were originally designed in the building, but for some reason they were never installed, just purely from the cost at the time. So late we've installed 6 new escalators in the building in the last 5 years. We have 25 lifts with a future 9 more lifts to go in, which painting is going on at the moment, mainly to address the issue of accessibility. When the building was built in the 60s, the concept of people in wheelchairs or people with disabilities trying to get access into the building was never considered. And if you visit the building, you realise the steps are just diabolical. It's to the point that we actually have to have a nurse on site all the time to just not only deal with the issues of staff, but the people who stand and trip and fall in the building. It's sad. And there's some other statistics on the building. Probably the most interesting one out of that sort of group is a figure down here. I'll take this one. 12 million litres of air per day is circulated through the building. 56 plant rooms provide that air. They're scattered all the way through the building, underneath it, on the sides, on the top. And when we go into the detail, you'll actually see that we don't have a roof and we don't have a back door. It's all hidden within the building structure itself. This is the very basic outline of the building. On the left-hand side up the top there is the concert hall, and this is the internal part of the concert hall here. The next space beyond it is the playhouse, the drama theatre. The drama theatre is located at the bottom underneath the concert hall. Below that we have the studio, which is in this green area here, and then a playhouse, which is this blue area. And they're the capacities of those theatre spaces. On the right-hand side of it is the opera theatre, which occupies this part here. It occupies the whole building on the right-hand side. And it seats 1,500 people, and then a little tiny space at the front here is called the Utzen room. And the Utzen room is the only place which, fortunately, Jan Utzen was actually able to have an input before he passed away. It was his idea of what he wanted the rest of the building to be. I see a lot of it when I walk around Denmark. Beautiful timber floors. In Australia, it's more concrete or granite or something like that. The Utzen room is one of the spaces where they actually did what he requested, and we have wooden floors, which gives you this, for us, it's just this fabulous smell of timber, which lacks in a lot of the other rooms. And then the final space we have is the forecourt, out the front of the building here, which will accommodate 6,000 people. By legislation, we're only allowed to have 6,000 people. Before legislation came on board, there'd be concerts held out there would be in excess of 70,000, 80,000 people. Just everybody turned up. It's all now, it has to be fire compliant, risk and regulation, occupational health and safety. This event on the right here is when Oprah Winfrey decided to come to Australia and do three live afternoon shows from the forecourt of the Opera House. It was an absolute diabolical logistic. She was nice as well. So this is the size of the building. It's only 125 metres wide, 250 metres long, and as you see on the front here, it's totally surrounded by water. As I said before, we don't have any back doors. We can't throw the rubbish out the side and pick it up later on. It has to actually all be contained within the building. We don't have a roof where you can stick plant and equipment on the top. There's no visible pipes or vents or anything coming out of the top of the building. It's an absolutely unbelievable engineering design at the time and still remains to this day quite an amazing building. So going through the building, I'll take you up from the basement of the building. Actually, go back one. We have just finished a major underground loading dock, 4-year program to put the entry and exit for all of our vehicles that come on site, rather than running down the main road here and along the side of the building into this area here. We've developed a tunnel entrance there and gone down underneath the building. A 4-year project, 16 metres below the building, with 2 main tunnels running up underneath and lifts connecting up into the other side of the building. This is the basement level of the building, what we call basement 4, which shows that tunnel entrance coming down. A loading dock in this area here, which can accommodate 3 semi-trailers, 2 rigid vehicles, rubbish trucks, forklifts, outside broadcast vans, all self-contained down there. We also have, for the first time, chilled rubbish storage. So summertime, and Australians like their seafood, they like their shrimps. You can imagine at the end of the day, a heavy drinking and eating session. The next morning the building stinks of seafood. We at last have a place where we can contain in a chilled environment our waste rubbish and have it being taken away by trucks overnight. The next level up is basement 3, which strangely enough to me, I had a friend, a colleague of yours from Denmark in the building. I said, come down to my office. And my office is in a basement, and I have no office windows, and that's been the way I've been for 15 years. Lots of people work underground without windows, and he said, you can't do this is illegal. And it is illegal here, but we actually, this structure in here, this area here is being developed as a new contractor and staffing area with accommodation for about 60 people underground. We then move up into the basement 2 of the building, where with the new structure, this new loading dock actually integrates into the original building structure. And when we get to the basement 1 level of the building, this area here is one of our most popular food and beverage outlets on a Sunday, on any day of the week in the afternoon. It's to the west. It's got the harbour sitting right beside it here. And it's one of the most popular outdoor drinking and eating areas in the central business district. It gets absolutely packed on every day of the week. It integrates then across into the building with our main plant rooms, and we start to get the lower levels of the first 2 performance spaces. Then move up to the ground level of the building, and you start to see the forecourt coming on board, and the 3rd performance space coming in here. And over on this side here is the lower level of the opera theatre, where we bring in the sets that will then be lifted up onto the stage up above. And we move up through the building, level 1, level 2. Level 2 is basically our administration, the green room. If people are familiar with theatre terms, it's our food and it's our staff canteen area. Staff canteen area is in the central here. And around here are all of our main staff rooms, dressing rooms, conductors' suites, rehearsal spaces. And then the building starts to move up and we get into the main 2 theatre spaces, the concert hall and the Jones Sutherland Opera Theatre. And down the back here is the Bennelong restaurant, which is a purpose-built restaurant. It's one of the best. It's just won a 2-star, equivalent to like Michelin 2-star, which is it's just won 2 hats in the Sydney competitions in the last couple of weeks. As the building moves up, you slowly see the structure rising up above it to the point that we get right up to the top, and all of a sudden the shelves sit over the top. So our biggest constraint in everyday operation is not only just the limited space, but it's also these massive, strangely shaped shelves that stop us from going anywhere. We just have to stay within this rigid concrete structure. We have a lot of records associated with this. At completion, there's $102 million in '73, but on top of that, a lot of work has been done over the years. It wasn't until about the building opened in 1973, 74, and on this side here we have repairs and maintenance. For a long time, it had cost the government so much money that they just literally said, let's just walk away from it. And literally, they just let it just go along, just surviving on how it was working with the equipment that we had. And it wasn't until about in the early mid-90s that all of a sudden I said, well, we've got to do some maintenance on this building. And all of a sudden, a whole maintenance program started to commence. And on an average, we average between $28 and $32 million per annum maintaining the building. On this side here is capital works that have been done to the building. So again, for the first period of the building, it just, again, it cost the government so much money that they just left it sitting there. And then all of a sudden in 1988, which was the 200th bicentenary of Australia, they did one of the first projects, which was that lower concourse area, the food and beverage area that I talked about a moment ago. They built that. And since then, we've been doing major works going through, and you'll see later on where these works have been done. I mean, this is the $153 million project of building the underground loading dock, which started around 2011, 2012. And we've just got funding for $200 million worth of accessibility. That's how much it's going to cost to get people into the building. Because the rule is, if you want to sit in the very back row of a theatre space in a wheelchair, which everybody in a wheelchair is entitled to, from the moment you arrive on the site to the point where you're going to sit, you have to be able to get yourself there under your own mobility. In other words, we've got to provide access from the gate to the actual seat, and that's the major project that we're facing at the moment. So why should we use BIM? The short answer is, and as Tobin said before, there was no reason to start. It just happened. We had an enormous volume of records. I inherited a room full of drawings and microfilms, and just being my typical sort of analytical anal self, I wanted to put them into order. And basically that's what I did. I just started sorting these things and putting them into order, throwing out redundant pieces, and it was a one-man band. I was all by myself doing this. The other thing is we're serendipitous. It was just, we needed to do something. And I'll go through these four points about the information and how we've been indexing it and making it accessible. And then I'll touch on the other 3 points down below there. This is drawing number 5 by huset. He did this in January 1959, and it basically sets out the grid of the building, which we still use to this day. The policies and procedures that he implemented from day one is still held sacrosanct to us in our daily operation. That's a view of one of our drama theatre and a model, trying to get more people in, adding an additional dress circle area up the top here to increase the space by 400 people. Obviously we have electrical distribution diagrams, hydraulic diagrams, all the rest of it. That type of typical engineering documentation. This is one of the Revit produced documents for the underground loading dock. All of the modelling that was done for this underground loading dock was done using Revit and using BIM, and I'll show you that later. But we required everything to be done as all drawings had to be derived from the model. If they weren't derived from the model, it would be like a subcontractor who might have facilities and had to do a specific task. One of the projects have actually put in traffic management on the site during construction. The building remained open for the whole 4 years. Put an enormous responsibility on the contractor to actually work between basically midnight and 6 o'clock in the morning for 4 years. Because during the day, you had conductors doing rehearsals, and the last thing they want to hear is knocking and hammering and drilling or anything like that. And being a concrete structure, you could knock something in one corner of the building and you'd hear it in the other. So, I mean, it was a major challenge for them to actually work this project. This is the overlay for traffic management during the Oprah Winfrey conference performances. Literally, the city shut down, the northern end of the city shut down. Everybody had to have identification passes if you worked in the area, but also on top of that, for the patrons who were coming in who had actually won a seat at the concert, they had to be, vetted by security. Unfortunately, the Opera House is the prime target if ever there's anything that will be done regarding terrorism in Australia. And that is sort of like the overlay that we keep in the back of our minds all the time. And that's why the security and the systems that we're putting into place have to address that all the time. We get operating and maintenance manuals, O&Ms as we refer to them. We have an enormous developed set of photographs basically recording the history of the building from day one right through to present day. This image up on the top left here is 1988 when they actually built the lower concourse area, this food and beverage area. And this image down here is the work that we just did 3 years ago. And that's the common area just here. So this is the underground tunnel that was built on the fourth floor. And as you can see, we had to keep the building open through the whole time. This is what we dug out underneath the building. So, an absolute challenge, an historic engineering feat, and someday it'll be written up and you'll see it in documents about how it operated and how they actually did the work. Regarding the volume of documentation, we did the Western Foyer project, which was integrating a series of three lower theatres on the bottom side of the building into one uniform foyer space. And that photograph is actually a photograph of the foyer space that was resulting at the end. It cost $38 million, and we ended up with 23 hard copy manuals, which occupied in my compactors 1.5 shelves, about 800 megabytes of data. On top of that, we got 55 archive boxes of data, and I sort of thought, if I stick them into a shelf as well, how much space would that be worth? And we came up with about 4.8 gigabytes of data, if that was scanned and put into the system. We received 6 DVDs of the project, again 4.8 gigabytes of data. So in total, for a $38 million project, we ended up with 34 gigabytes of data, which we put into our database. It is current and it is searchable. So all of this information is available for you, and that was just part of the early stages of actually putting our house into order, is the best way to describe it. For those people, we call the Opera House the house. It's just a local term, because I mean a lot of people who work there, it's like going to work every day, it's like literally going to your other home, because it is one of those buildings that has just got the most amazing sort of feel about it, that you don't feel like you're actually going to work, you're actually going to the other place you live at. And even though I might be in the basement, I don't regret living in the basement for the last 15 years. This information, there's some more of the information that we have, 30,000 drawing sheets, microfilms, CAD files, model files, operating manuals, and all of this is placed into this, what we've developed, our own internal access database, which is going to be moved across to a new system in the next few weeks. The policies and procedures that we worked out, obviously to put all these things away and keep sort of a standardisation, we had to develop some of our own rules and regulations to do the work. So we created the rules. In information compliance, there's some of these guidelines which were coming through. That document here is our conservation management plan, which has just been re-released. It's about that thick, and it literally dictates or recommends what you can and you can't do, because the building is actually UNESCO listed. So not only do we have a conservation management plan, we have a UNESCO inscription on the building. The court, Wilson in 2002 was kind enough to actually sit down and give us his ideas of what his principles and processes were for the building, the future of the building, what would happen after he passed away, what was he allowing the building to do. And one of his things was, he said, this building cannot remain stagnant. It is not going to be a time capsule of when I finished it or when it was finished. It has to move with technology and performance requirements, particularly as a performing arts space. It's about a quick summary of how much policy documents, safe work procedures and master plans that we have. And for any unsuspecting contractor who wants to do a job at the Opera House, they're basically given this as sort of like a reading material before they even start reading what the tender is that they're going to start working. It certainly sorts the load. It sorts people out very quickly. We developed our own internal policies and guidelines, CAD, BIM guidelines, coordinated grid system through the building, how you actually write an O&M, operating and maintenance manuals, technical numbering down to the point of, why do you call this door in this certain format? We have strange codes which are like door numbers T5017, and on the other side of the doorway it might be A5016, and I mean it all relates to the purpose of the rooms. Unfortunately, the space themselves, like this large room here, has a very rigid numbering system. It's for the ground level of the building, so this might be called G501. But the doors outside could actually be numbered. The numbers of the doors don't relate to the space you're walking into, which is just an absolute nightmare. So we have a database that relates doors to rooms. Our drawing numbers, it came from Stenson Environment, and over there in '66. I've been working at the building for about 2 years in this room by myself, looking at all these drawings, and I could not work out how the drawings were numbered. It was never, out of the 80,000 microfilms which I was looking through and everything else, and then one day I came across this document. And this document basically defined how you broke the building up in engineering disciplines, and if you go back a little bit, notice down here, there's the levels of the building, and they've all got compartment names. And effectively, they are fire compartments, broad fire compartments. So what you would do is you'd be looking for 53, discipline 53, and then certain fire compartment, which is the next number along here, and then you'd allocate the next drawing number to it. So that, to me, was like finding the Rosetta Stone. All of a sudden, I realised what the numbering system meant. In the VAPS project, that underground loading dock project, we used exactly the same numbering system to this day, and we still do. We even name our models according to this numbering system. And the beauty is, it works, why break it? It's got so much legacy documentation in the background. To rename everything just because someone wants to do it a new way, I just can't see the purpose in that. So we adopted that same sort of numbering system to this day. Survey control throughout the building. We've placed through the building a network of 165 brass plaques which provide you X, Y and Z values, and also identify on the brass plaque the area, the fire compartment area that you're in. And the way that these are being positioned for a surveyor coming on site, he can usually see at least two no matter where he stands in the building, so he gets coordination. So particularly nowadays with laser scanning, he captures the brass plaque as part of his laser scanning project, and straight away we know exactly where that is located. That is accurate down to 5 millimetres. It was done as like a first order accuracy by a surveying company. It took 18 months to survey to get the brass plaques laser engraved and then placed into these positions. That is the Australian map grid coordinates, so effectively you can walk into a GPS system, and if you could actually get a satellite image, a satellite link within the building, because there's so much steel and concrete, it's like a Faraday cage. If you could get it, you could actually confirm your GPS of your phone system against our brass plaque. And then we've been using laser scanning. This is an image back in, it was about 2010 this image was taken. It was sort of like one of our works areas, and this image was taken only about 3 weeks ago, and the quality of the imaging in laser scanning is getting to the point. It's just like photorealistic. It's just like taking photographs. Absolutely amazing. So the technology that have been advanced, been developed. We had the technologies. We looked at what we were We walked, gone through the IS groups. We tried to look at the computer systems that were available. We had the information policies. We had everything basically sitting there, ready to go. And then an opportunity came along. This was in 2004 when we first really embraced the concept of what BIM could provide to the Opera House. We were chosen as an exemplar project, and no doubt if any of you have done a scan on facilities management, you've no doubt seen this image of this document. It was basically the first time we had participated in such a thing. We had research, we had academia, we had industry, all working together, trying to come up with an integrated framework for FM. And it was the basis of where we started work. It involved two principal groups, the Construction Research Centre for Construction Innovation, which these days, in typical acronym land, they're called the SBENRC nowadays, Sustainable Built Environment National Research Centre. They changed their name because they got funding from a different place. And Facilities Management Association of Australia were the prime drivers as well. In 2006 we released a revised set of BIM guidelines that actually took on board what the Exemplar project had given to us. We developed our first, CAD guidelines, and then we developed our first BIM guidelines, and it was basically a general overview of what was BIM and what impact it would have on us into the future. In 2011, this underground loading dock project commenced, and its full title is actually, we call it by the acronym VAPS, but it is literally Vehicle Access and Pedestrian Safety. It's basically giving the site back to the 8.2 million visitors that walk across it and removing the trucks away and putting them underneath the building. It involved all of these various engineering disciplines to actually get the project started. That was one of the key things that sort of started on our way. We were fortunate enough in 2012, as Scotland celebrated Historic Scotland, their 150th anniversary of having this group called Historic Scotland, had tied up with a group called SIARC. And Ben Kassira, who is the founder of SIARC, he actually had the royalties to the laser heads, laser scanning heads that a lot of the companies use to this day, like I did. And he was such a wealthy man out of that royalties that he became a philanthropist. And basically he was sitting watching the day that the Taliban destructed the Buddhas in Afghanistan in 2011. And he was watching television and he said, if I could have caught that with my technology, we would have it forever. And it was basically, that's what started him. And he said, we need to go out and capture objects around the world that are meaningful forever, because if they're destroyed, they're lost. But if we can capture it in laser, with laser technology, we've got it as a sort of like an image that we can refer to the future. So between him and Scotland, the Scottish government, they chose 5 Scottish sites to do work on, and they chose 5 international sites, and the Opera House was chosen as the 4th international site. All of this was done free of charge and delivered to us on a hard copy. All we had to do was provide the space and offices for them to sit in. It was absolute $500,000 worth of gear. So the key essentials were ready to undertake BIM. We had the technologies, the survey, the policies, and the information. And if you go and actually look at what I've used as a current reference of what building information BIM is all about, it's combining, as it reads there, building information modelling is a set of technologies, processes and policies enabling multiple stakeholders to collaboratively design, construct and operate a facility. So that is, to me, the driving force behind what BIM should be all about. How to implement BIM. So I'll very quickly go back to the VAPS project. This is a plan of the site of the building, and as you know, this is the water around the outsides of it. And we get 8.2 million people walking onto the site. This is a cliff here, and this is a raised, probably about 10 metre high. This is the Royal Botanic Gardens and the government houses behind our site. So most people walk through a little tiny space here, which is only about 30 metres wide, onto the side. You get some people entering from the botanic gardens around this side, but the majority of our pedestrian traffic comes through this one small space. That's our main road into the building. All the trucks, deliveries, taxis, buses, everything come through the same space. So we've got this very, very tight space, and this is just indicative of sort of like what goes on a daily basis through there. The current loading dock to the building is located here on the side of the building, which is this thing image down here. And I'll show you in a moment what happens because the building is so restricted in size, and we have a repertory opera company that rents the space. They can't sing, a typical performer in the opera cannot sing for more than 2 consecutive nights. So with the number of performances we actually stage in the building, the opera has to change at least twice a week, put on a different show for another night, if not maybe 3 different shows in a week. So all the sets that are involved for those shows, we can't store on site. We've got no storage space. So literally what happens is trucks arrive on site early in the morning. Excuse me. Trucks arrive early in the morning and literally they drive up the side of the building. Right to the top, come around the very top. This is a fixed post identifying where you are in the building, or a sign beacon. They get to the top here and do a 3-point turn and then reverse back down inside the building. Once they're inside the building, that's about how jammed it is inside the building. They literally just fit the trucks. They know the clearances in the building, so the trucks are actually, they choose the right trucks for the job. They come in, the guys offload the sets out of the back of the semi-trailers, reassemble them, and then push them onto the opera theatre staged area, and it's lifted up onto the stage up above, which is 15 metres above. So that happens usually between 11 o'clock at night and 5 o'clock in the morning. So not only have we got rubbish collection going on, we've got sets being disassembled and repackaged and put into truck. And at the same time as one goes away, the next one's being bumped in for the next event. And that's just for one theatre. We've got 5 theatres doing this. So the same thing happens all the time. It is unbelievable, the number of vehicles that we have. So the idea was to remove the trucks from going around the side of the building and build an underground loading dock that went underneath the building, with connecting tunnels underneath the 2 theatres, the main theatre side, and 5 new lifts that would actually take the sets and stock and produce and people up and down. I should mention to you as well, down here, this area down here, this is the Opera House car park. It's a 12-storey deep double helix car park underground, which has arms coming out where the people actually walk out onto our lower concourse, and the vehicle access is further up the main road. So this is where everybody comes in and out onto this, from this car park as well, in the morning and the afternoon, working in that end of the city. This is some images of what the proposed project would be. This tunnel going down underneath the building, leading down to this large loading dock. And this image here, I took this 3 weeks ago. This is what we've got now. This is what has been built. It hasn't been handed over to us. The contractor is still in the last stages of finalising the project. But as you can see, these gantry cranes that were designed over here, that's what they are here. Big enough to actually pick a container off the back of the semi-trailer, move it down in the corridor, ship it to the side, drop it off, and we can store 2 containers of sets. And at the very end, the lift at the end is 6 metres wide by 10 metres long with no roof. So basically we push things in and just lift it up from minus 16 metre here up to ground level 0. 50,000 vehicle movements per day, per annum go across the site. 1,800 events and 8 million pedestrians. So it was a fairly large project ahead of us to sort of solve the problem. The infrastructure at the time, as I said, this is a 30-metre wide space down here. What we had coming in there was the harbour tunnel. 6 metres below our site, we have the second main harbour crossing for Sydney. It carries 10,000 vehicles per day, and that sits 6 metres below our site. We've got the Opera House car park, as I described, sitting down here with these tentacles of air intakes and vehicle access and everything sitting over the top. We've got fire and water supply to the building. Our main water, our domestic water, our drinking water literally is taken off our fire supply lines through, filled it and taken that away rather than having a second supply. We've got a gas supply into the building, 1,000 kPi, 150mm diameter pipe supplying gas to the kitchens and spaces. It sounds like an enormous amount of gas. The trouble is, the original design for the air conditioning systems was they were going to be gas-fired, but it just proved too difficult at the time it became electricity. That large main still remains coming from both sides. We have electrical supply that comes in, and we have 2 substations within the building, which is sufficient to supply a town of approximately 40,000 people. It's a big number, but that's about the size of what we've got there. And then on top of that, there's this line going out here, is the supply line to a lovely little island in the middle of the harbour, which is sort of like it's one of the principal sort of navigation points for the harbour. So all of that power supply for it runs up the side of the building and out into the harbour. We not only take our own sewage out of the building, but we're responsible for taking the sewage from Government House out of the building. It runs across the front of our forecourt and out, and it's all happening down here. Just keep an eye on what's going on down in this space. And then stormwater. Not only our subsurface drainage, but one of the main stormwater drains from the site actually runs right through and underneath the building. What we had to do with this DAX project was literally, first stage was reposition it. So it now runs out to the side here. We had to turn it around and run it out there. Communications, our fibre optic and telecommunications, plus the events on the forecourt are all linked into a full network system, so we can just lift manholes and plug in fibre optic cables, television links, everything. So the whole, like what you saw, the Oprah Winfrey performance, that is all happening, just literally the services are there already. And then we have security. We have major pop-up bollards and road blockers that just activate, and these days they're constantly up and they drop down for vehicle entry and exit. So all of this is sitting in this one space, and all at the time the documentation was all just in paper form. We didn't actually have anything in any true electronic. So this was the opportunity we had to actually document the paper and convert it into what we would call our electronic form. That's a long time. The thing that we did ask for people to do was to actually collaborate and deliver back to us at the end of the project as-built model and a confirmation point cloud of the work that was done, O&M documentation in electronic format, and an asset database of all the objects that have been put into it. A very simple form of an asset database, nothing more than an Excel spreadsheet. We didn't want any complications at that stage. We just wanted something simple that we could repurpose the way we wanted to do it. And then on top of that, we wanted to integrate our current 3D model with this new model underneath into it. So what BIM benefits did we achieve? Probably the best thing is to look at a life cycle. The Opera House, we're all pretty used to this sort of concept of how the life cycle works, starting with concept design and going right through the whole process to operation and maintenance, and either renovation and starting again or demolition. The interesting thing at the Opera House is we started in '47 with these various projects that came through, and I'll quickly flick through them. Goodson were winning the contract in 1957 and construction starting in '59. And then in '73, the Queen Elizabeth II opened the building. And this is where I was saying before, these projects, these capital works projects that came on, the lower concourse was revised and the forecourt was updated. A venue improvement plan to just improve things like toilet facilities and box office areas. The Youths and Room was opened in 2004. The first part of an extension to the building to provide sun protection to future openings along the side of the building was built in 2006. The western foyers and two escalators were put into the building, and in 2015 the HAPS project, this vehicle access and pedestrian safety. So if you take that project and look at it as far as a life cycle, the Opera House is deemed to have a life between 250 to 300 years. We're that far into our life of our building. It's not going to be pulled down next week. And it's not going to be pulled down when the accountants say, well, that's 40 years, that's the end of the depreciable life of this building. We're there for a long time. So what we're putting into place is fairly significant systems for the future. We've been using Bim as a catch-up tool. You probably recognise most of this work here, and running a little bit. Taking us through all the different sort of use of electronic information. The Scottish 10 project came on board and provided us with an enormous amount of information. We look at the structure of the building, that's the southeast elevation of the site. The concert hall in a longitudinal section. The Bennelong restaurant as it stands at the moment, and as a longitudinal section as well. And you can probably even see the tablecloths draped on top of the tables. That is the ground level of the building. The main central passage where those trucks were parked, and this is the loading, this is the opera theatre dock area where the sets are put in there, and that's our main plant room. So we have been building this building up quite significantly using the technologies and the tools and the resources that we've had. We've imposed some amazing sort of grid systems on people who work with us, and we get confirmation of this overlaid on the top of that, and what we're getting is absolutely coincident interfaces to the point that it actually twinkles when you look at it online, because the two are actually so coincident to each other. The last part of this thing is what we're going to do, which is the Bim for FM section. We had all this information, the model, and all of our building control systems were coming together, and what we needed was one single interface into it so that we could actually use this. We knew ourselves that we didn't have the skills, we knew what we wanted, but we didn't know who was going to be able to provide this service. So we actually went out into the world and asked people to provide their services to us, to actually work with us to develop a FM solution. We shortlisted out of 200, well, we ended up with 84 organisations from 8 countries, of which 36 successfully completed an online questionnaire, 250 odd questions, and we ended up with a resource pool of 22 companies, and they were 6 BIM specialists who specialise in actually the whole concept of BIM, 10 solution providers, which were the software houses, and 6 architectural engineering and construction organisations who were actually doing the work. They knew how to do this. And we call that our resource pool. We then went on and we did the successful tender of a technical specification which went out, and we ended up with the second tender. And in the second tender was when we said, now that we've got our technical specification, we now want someone to do it. And the same 22 companies that were actually in our resource pool, we actually asked them to develop consortiums between each other and to deliver the resource to us that way. So at the end, the contract was awarded. The contract was delivered to these 3 companies, an Australian company, BIM Academy and Ecodomus. And literally, we had our first kick-off meeting last Wednesday, and the implementation stage is due to be completed by March of next year, and beyond that, we're not quite certain what we're going to get. I think I'll leave it at that point, because otherwise I will talk on and on. But thank you very much. It has been an amazing journey for us. It's a long journey. The thing is, it will cause a lot of people a whole new way of thinking how you do your work. It's one of the principal things out of it is the fact that it is a paradigm shift. People will resist it, but in the long term, the benefits are far exceed the problems of just getting personalities. Thank you.
I know the people here have a variety of questions for you, and therefore I will announce and invite you to join Chris's workshop just after lunch or record to 1 o'clock if you have questions and if you want to go into details with the presentation here. You're all invited. Thank you very much for an interesting story. It's nice. I could give you lots of comments. I won't because we're running late. But one comment though, I think it's nice to know, being Danish, that you take good care of Bjørn Ulsson's house. So thank you very much. Thank you very much for that. Ja, så skal vi til det. Vi starter 15:15 sharp i alle de 3 spor. Så herfra, have en rigtig god konference.